Let us discuss this example. In this example, we have a function cos 2t sin t upon e raised to t, and we have to find its Laplace transform. Okay, let me write a given function once again. We have what I'm going to do, I'm going to shift this e raised to t at numerator. It will be e raised to minus t cos 2t sin t. So this is a function we have. Actually, there is a product of three different functions, but no need to worry, we can solve it easily. E raised to minus t is there. That means, as I told you earlier, when we have exponential function, we have to use first shifting theorem there. Okay, so that means mainly we have to focus on product of these two functions. So let us find its Laplace first. After that, we will use first shifting theorem. So we can consider that e raised to minus t also. So I consider Laplace of cos 2t sin t. So now the question is how to find its Laplace. Since there is a multiplication, there is a product of two functions, and we don't have any formula in Laplace for the product of two functions. So here we have to use the knowledge of trigonometry. See, one formula we have already seen in trigonometry, that is, let me write here, 2 cos A sin B. Do you remember this formula? The formula is sin A plus B minus sin A minus B. That angle I have written here, since there is no more space. See, this formula we can use there to make them separate, getting cos A sin B. But the question is, there is 2 and we don't have 2 here. It's 2 is a constant, we can easily adjust. So that's why. So this is equal to, I am adjusting, multiplying, divide by 2. So 2 cos 2t sin t. So now we can apply the formula. What is A? A, angle of cos 2t. What is B? B is angle of sin t. So let us use that formula. This is equal to 1 by 2 Laplace of, the formula says sin A plus B, 2t plus t, 3t, minus sin A minus B, 2t minus t, t. I wrote directly. Minus sign is there, so we can take separate Laplace. So this is equal to 1 by 2 Laplace of sin 3t minus, see, 1 by 2 is a multiple to both terms. So 1 by 2 Laplace of sin t. So you know the formula of Laplace of sin at, a upon s square plus a square. So that formula we can use to find its Laplace. So let me do here. This is equal to 1 by 2 into Laplace of sin 3t is 3 upon a square plus 3 square is 9 minus 1 by 2. Here we have to write Laplace of sin t. So multiple of t is 1. So the formula says 1 upon a square plus 1 square, which is 1. Okay. So let us multiply, make it simple. 3 upon 2 a square plus 9 minus 1 upon 2 a square plus 1. So the major task is done. Now simply e raised to minus t is there, additional term. So we have to use first shifting theorem and solve it. Let me write by first shifting theorem. Laplace of e raised to minus t, what we have, cos 2t sin t. As I told you earlier, so okay, what simply we have to make some small changes. This Laplace already we have. What is my multiple of t? Minus 1. So that means we have to replace s by, can you guess? S plus 1. Everywhere we have to replace s by s plus 1. So it will be like this, 3 upon 2 s plus 1 square plus 9 minus 1 upon 2 s plus 1 square plus 1. If you want, you can expand the bracket. So 2, I am expanding the bracket, s square plus 2s plus 1 plus 9, 10 minus 1 upon 2. Okay, I am using this space simply. 2 s square plus 2s plus 1 plus 1, 2. If you want, you can further cross multiply and simplify, but this is also you can consider as a final answer. Okay, I hope you understood. Make a screenshot of it, then we will stop. Thank you. Bye bye.